So let us say some more applications like halogenation of alkanes when you say. As we have seen, when alkanes treated with halogens like chlorine in presence of UV light, it first gives the R dot, not the final product as such, isn't it? First Cl2 breaks up into dot. So this gives the first Cl dot, and that Cl dot attacks, and the HCl is formed by product form first. R becomes into R dot. Then this will be turning into the product RCl. Okay. So in the halogenation, we find its intermediate free radical. Even the free radical, as I said, it shows hyperconjugation. Now a compound like, for example, if you take a isobutane, it has a 3 hydrogens, 3 hydrogens, 3 hydrogens. These 9 hydrogens are identical. Any one of the hydrogen, if you can halogenate it, you will get the same product, that is isobutyl chloride. Isobutyl chloride. If the hydrogen which is there in the center, if this is halogenated, you will get another product, that is second type of the product, that is tertiary butyl chloride. Tertiary butyl chloride. So two different only two answers. Any one of these 9 will give one answer. The middle hydrogen will get that. So how many answers means how many types of hydrogen, therefore we are answering. And out of this, which is more stable means already we have seen with reference to the free radical stability. So in the first case, the free radical will be the 1 degree, right? This is the 1 degree one. Whereas in the second case, the free radical for this one is 3 degree. So this is 1 time stabilized, that is 3 times stabilized, and therefore this is the major one. So this identification of major one through inductive effect, because it has 1 plus I effect, here 3 plus I effects are there. So therefore this is major one. Hyperconjugation not necessary. Based on the inductive effect, one can decide how that is the major one, because it is 3 degree one. So 3 degree free radicals are more stable than the 1 degree. Therefore major I1 identification doesn't require any hyperconjugation help with the inductive effect itself. But what is the expected ratio? In fact, if you see the probability type, 9 hydrogens will give this 1 hydrogen. That means in one way, based on the probability, you will get the 9:1 ratio, because 9 any one you get this one, only the middle one you will get. So 9:1. But the probability will not be the criteria. Here stability will be the criteria. Based on stability also, if you apply the inductive effect, this is 1 degree, that is 3 degree, you may go for the 1:3. None of them is correct. This is totally wrong, because the major product is that one. Some extent it is right, 1:3, that means 25:75. But what is the actual product when you compare means, actually the 1 degree free radical has only 1 hyperconjugable hydrogen. This is the only 1 hyperconjugable one. Whereas this one has a 3 plus 3 plus 3. So 9 hyperconjugable hydrogens are there. So some extent this is correct, but almost it is 1:9 based on the hyperconjugation. We guess it, and many times the ratio also, with reference to the hyperconjugable, the hydrogens coincides. So the expected product, especially not in the chlorination but in the bromination, it more or less it is coincides with the expected ratio, because bromination is the more deciding, slowly reacts, and the most stable will be chosen. This is also asked one in IIT examination. The photobromination of isobutane is going to give 9:1 or 1:9, like that the question answer is 1:9. Tertiary butyl chloride comes 9 times over the 1 butane. That is, here the intermediates are going to decide the stability ratio with reference to the number of hyperconjugable hydrogens.